your pictures here real quick. But then I got to get out of there. Okay. All right. So real quick on the calendar, we were talking the teachers for math 2 honors. We didn't want another written quiz. Like, I think it's really after today a good spot to have a quiz because tomorrow we'll do the factoring, which is the reverse of multiplying. So everything we've been doing has been based on multiplying polynomials. I pretty much feel, and then the graph analysis of it, which does involve the zeros and all that. So what we decided is we're going to have a quizzes on this Wednesday, but it's going to be for real, like meaning it is going to be a quiz grade. You're going to be assessed exactly what you get on it, kind of thing. So we just kind of wanted it out there so then the people that are at home, it's equal. Everyone has something that will get a quiz grade halfway through this unit in a appropriate spot. So just give you a heads up. I always like making sure you're informed about what's going to be happening, and then we'll talk more about that on Wednesday itself. Tomorrow I am going to move on to the factoring though, so just so you know, we are going to keep going with the flow and blah 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 blah. Okay, so today, last day of like multiplying. This probably could have been Friday, but I did really want to insert binomial theorem because it's a really kind of a neat thing to take binomials to greater powers. And then I hope you found those last questions that you had to do kind of easy. You didn't have to expand all the way out, but finding one particular term makes it pretty fast. But the whole general idea of taking the place of multiplying out. All right, so spend a minute to go do A, B, and C. You should be able to do that. And then we'll wait. Sorry for those on YouTube. We're just going to have a little pause here. Then check yourself before you wreck yourself. So do A, B, and C. C is just asking you to list transformations. So probably shouldn't have started the video, but that's okay. I don't have a pause option for those sitting at home, so you can just pull the bar to where reveal the answers. And I'm just going to reveal what we got going on there. Oh, did I take attendance? Darn it. I can't take it while we're taping this, so I have to wait till after. Okay, so we do have that one. Knew about that one. Knew about that one. And my last rowers. Okay. 3. Oh, and then, since you can kind of do two things at once, just just the old let's charge up kind of thing. We really are going to be looking to have that chapter 9 test here and then have nothing new. In my other class, my CAT class, I have a lot of people I'm trying to get caught up here. Even talk with Principal Green, and they were talking about a plan about those last 3 days. And I won't say anything yet until it's official, but it seems like there's going to be a little different schedule there because they are expecting teachers just to clean up, and get everyone finished up here. So make a big charge, man. And for pretty much we finish strong and end up being here and all that. You may very well be done on the 21st. Okay. But probably still expect you to come the next 3 days. Absences will be counted, blah, blah, blah. So, but just an idea there. Okay. So hopefully you remember your slope intercept form, or you remember that lines have slope. So many people got -9/5 as the slope, right? Right, right, right. Nobody? Right? Oh, okay. I was going to say, no one had their hands up. So, in order to get an equation of a line, that's a little different than polynomials. All right. Lines have consistent slope. So, we find the slope y2 minus y1 over x2 minus x1 going in order. And then I like point slope form. So I just kind of got lazy second hour and put it in point slope form, picking one of the two coordinates. You have to make a choice whether you use y equals mx plus b or y minus y1 equals m times x minus x1. And then we could distribute the -9/5 and add 5 if you wanted to put it in y equals mx plus b form. And it is actually supposed to be slope intercept form, so I am supposed to FOIL. Sorry, second hour. So y minus 5 equals -9/5 x. That's -18/5. And then I'm going to add 25/5, correct? So this is fractions 101. When I add 25 fifths, that's 7 fifths. There you go. This is truly in slope intercept form. How many of you got that answer all by their lonesome? One got an equation of a line, row. All right. So old school stuff. And then the next one, we actually did do this. We had quadratics, which I would call in intercept form. Call it that because that's correct. I don't know why I'm speaking that way. No, I missed the 9. Yeehaw. Let me get it now. There we go. All right. So do you remember this? Remember your P's and Q's? All right. Oh no. Who said no? Who admitted that? Is this frozen? Why did that not move over? Oh, here we go. Thought I had that there. Okay, so this was the standard form. No, wrong. This was the form when you had intercepts. This was intercept form for a quadratic. We did have the P and the Q as that unknown x-intercept value. Definitely had this. This is probably August or September for us, back in those good old fun days. All right. We've come a long way, haven't we? All right. So anyway, -3 comma 0. Well, you should know this from Thursday's notes. That means x minus a -3 or x plus 3. So that's why this is a plus 3 here. For that being a 0, that's what it would be for a factor. And then same thing with this. 1 being a 0, it's x minus 1. And then what's the point of this other coordinate? Point of this other coordinate is actually to establish an a value. To establish is my parabola going up or down. So I plug that in for x. Come on. Pen's acting like a jerk again. Come on. All right. And then -10 for y. And then what that leaves is that mysterious a value. Which direction is this parabola going with those two x-intercepts and that given other random coordinate? All right. And then when you finish this off, you get a -2. All right. So that's what that is in factored form. It actually becomes pretty easy to evaluate after that. If you were to graph this really quick, it would be upside down. See if I put this real quick here, 1, 0, -3, 0. And then this other arbitrary point, 2 comma -10, which is way down here. So yeah, this would have to be like this, and the vertex would be actually exactly in between these two x-intercepts. So it'd be -1 comma something. And that was something we talked about back in the day. How do you find a vertex from this? Well, it's got to be -1 comma. Then all I have to do is plug in -1 and find y. Input, say it, output. So that's kind of some other stuff that's going on here. All right, so this is really what's going to happen today. This letter B is pretty much could be considered an example for the day. But just as a reminder, remember your reflections and your shrinks and left and down, what that looks like in that format. Okay, and then for the purposes of just wanting to get this done, because it's going to be a lot of, foiling and all this other stuff, the notes are way too big. All right, so we are going to skip around. But I will do this first one. And then I'll pick a few here and there that are a little different that you might need me. Like we got some I numbers again. So I got to review what an I number means. But really, letter A is just like number or letter B in the bell work. If you want to write this down, this is what you're really trying to fill in. And I'll use P's, Q's, and then R as those x coordinate or as the x-intercepts. Those how those turn into factors from x-intercepts. And then right off the bat, I'm going to use the same color. Those are x-intercepts. So those go in those positions right there for the factors. And then same thing how I highlighted the quadratic, this other random coordinate that they're listing, that's what I can plug in for x and y. And lo and behold, all that I have left over is a. And then that's the point of this. Probably should have changed the color for y. So really not a big deal day today, I don't think. So this x value, be careful, is 2. So I better put all those 2's in there so I don't get lost in my question here. and then minus a negative 4, minus 1, minus 3. That's where those go. That's how this works. Polynomial zeros and then that other random coordinate. Then really make it easy. 2 plus 4 is 6. 2 minus 1, 2 minus 3. All right, that's negative 1. So be careful. This is negative 6a equals negative 3. I get this all the time that people say this is 2, when in fact it's a half. I have to divide by negative 6 to get a by itself. So do your undo operations, making sure you don't make that mistake. Now, one bad thing about this, no, it actually is not. Write a cubic function in intercept form. That's a good thing. And I didn't kind of pay attention to that in my first hour or second hour, actually. What that means is I don't have to multiply this out, but I do have to bring back the x minus negative 4, the x minus 1, and the x minus 3, and that is in x-intercept form. I can see from that equation the x-intercepts right off the bat. Oh, but now I would know something more, like this would end like this, because the a value is a positive, things like that. Talking about what you should know for graphing. All right, so intercept form's good. All right, less work for you. It's really more of the same. That's why I don't really want to go through all of letter B, but it's with the picture. It's given the same information. So I'm going to have negative 9 for y. A is going to be unknown. 7 is going to be the x value that's in each intercept form here. And then it's minus 1, minus 4, minus 6. And it's more of the same. Do I really need to continue and show you this that gets a new example? Yes or no? No? We fine with that? Is that okay? All right, so more of the same, but with a picture instead of a listed set of coordinates. It's really the same exact example. You can continue from there and get that, and it does say an intercept form, so it'll be very similar to this one. I think in the other one, I did keep my notes from the other class here. Just curious what the answer was. I thought we got like a half again. Negative half. Yeah, negative a half this time. Yeah, it couldn't be a half. That's a terrible thing to say because that would have to be a negative leading coefficient the way that ends for sure. Okay, now here's where you might need me. Little review on I numbers. And notice how that comes in what I would call a conjugate pair. Plus 3i is a 0 and minus 3i is a 0. Now, this one I definitely last hour did cover in full. And it does have a leading coefficient of negative 4, and it says put it in standard form. Now we're going to have to multiply out. Before I go on with this, though, I do have 3 zeros, 3i, negative 3i, and 5. I do want to cover this, what it might look like. Leading coefficient of negative 4, it's going to look like this, some way, shape, or form with end behavior looking like that. One of two things could happen with this one. It could either cross the x-axis at this position or this position, but definitely no more than that. So let's pretend it happens here. That is an x-intercept. How many x-intercepts do you see? 1. How do I know that? Because the other two zeros are imaginary. Do you remember this with parabolas? Parabolas had imaginary zeros when it was going up, and the vertex was above the x-axis, therefore not crossing the x-axis. You remember this? Right? And this is how we got imaginary numbers through the quadratic formula. Or down and below, all right? So in this cubic, it's impossible for your cubic to not hit the x-axis at some point. So it definitely has to hit it once, but that's what those two imaginary zeros mean for the graph. So I did want to review that, remind you of that, but it really has nothing to do with this question. Just wanted to throw that out there. What you have to do is quite simply this. Again, it's about, well, actually, it's not about. They give us the a value. What's weird about 3i is a 0? That means x minus 3i is a factor. Negative 3i is a 0, x plus 3i. And then don't freak out, but we do need a review about I. We got to remember that I is the square root of negative 1. Remember that, I hope. and understand why we had that little unit and had to do that. We did that within the quadratic formula, simplifying radicals and then throwing in what is I. And it's used for things like what's the square root of -4? That does not have an answer. Something times itself equals a negative. So what I do is I isolate the negative. What's the square root of 4, everybody? 2. And then what's the square root of -1? Well, let's call that I from here on out so I don't have to look at it anymore. It's really somebody just decided to do that. All right. And we need to have that memorized. But what is I squared? It's a free -1. And there's a difference between the square root of -1 and a free -1. And that's what we need to understand from that unit as well. Even in last hour, I typed it on my calculator because everyone trusts the calculator. All right. And where is the I button? It is the period button. And then I squared it. And just for giggles, just to show that that is a free -1. Even the calculator says so. And then we actually talked about this in the past too. What do you think I to the fourth is then? Huh? Huh? Remember what this was? It was a +1 because I squared is what? What's I squared? -1. And what's -1 times -1? 1. That's why I to the fourth is 1. Then the calculator gets goofy. Let's just have some fun with this. What should I to the eighth be then? Just think about it. Crap. Clear? What should I to the eighth be? It should be 1 again. Watch what the calculator does. I think this is when it starts the math stuff that makes this stuff happen gets a little bit of an error, gets a little glitchy. But what? What does that answer mean? Look at what that says. 1 minus, what's 2e -13? Anyone know what that is? What's 2e negative? That's scientific notation, right? So 2e -13 means point. How many zeros? Actually, it's 12 because then the 13 position is the 2. So what you just saw there was 1 minus 0.00000000002I. What is this essentially? That is essentially what number? 0. What's 0 times I? 0. This is a calculator problem. All right, so I thought I'd just share that with you that you have to read that as 1 minus 0I, which is 1. The calculator just has some sort of, you know, some sort of, what do you call it, programming issue there. All right, so I just wanted to share that from the old days. Maybe I went through that back in that time. I think we were all remote at that point. Probably. Who knows? All the back and forth stuff, right? Anyway, back to the question at hand. Do not multiply that 4 or -4 through until the end. All right. Especially not with these I numbers. Watch what happens. And this is why the conjugate pairs are nice. First of all, x times x squared. Keep your stuff in order. 3ix. Oh, and then -3ix. What happens, everybody? What happens? They cancel. And now it's time for our I squared. Sorry, last hour I did -3 times 3 was 3 for some reason, or -3, but it's actually -9. I squared. What's I squared again, everybody? -1. What's -1 times -9? 9. So now what this is -4 x squared plus 9, and then x minus 5. So standard form, we do have to multiply out. So read your directions and make sure you do follow that. And then this is actually not that bad. X cubed minus 5x squared plus 9x minus 45. And then you go ahead and throw through the -4. That's why I don't want to bother you too much here today. We got way too many examples. And that's okay. I just don't feel like going through them. I don't think you need me to either, right? Don't you agree? Huh? Okay, so just for questions like letter D, I'm not going to go through it all the way, but just looking at this last thing, f of 1 equals 30. Input, say it. Who's the input number? 1. Who's the output number? So this is just a sneaky way of saying this is 1 comma 30, an arbitrary other point that this polynomial passes through. And then it really turns into exactly example 1, right? Or 2. It just turns into this. It's just a different format of the same question, right? Does everyone agree with me on that? So I can move on. All right. So I don't really have to do a fumble. And let's see if there's anything else that that I could be of use for. I even canceled that whole third page. Just looking at this, write the equation of a cubic in transformational form. In my second hour, I started multiplying this out in case it did come to that. Well, I guess we won't really do that. I'll talk about it. But in transformational form is actually a better thing. I could just write this answer down. 2 left, 5 down. So now it's a cubic. So it's 2 left. Remember, that's plus 2, right? And then down 5 is minus 5 on the outside. So remember those transformations and how they work and how they look in a particular function. The vertical stretch of 4 doesn't say anything about flipped or anything like that. So no reflections over the x-axis. So that's the answer. That's it. Now, in the other hour, I did say if you had to multiply this out, be careful because you would have to do this first before you would multiply that 4 all the way through. And that is true. So, and I did kind of talk about that and do the whole question, but just be aware of that. You'd have to cube, then distribute a 4, then subtract a 5. But it says transformational form, so I'm going to stop. Then I think I only really had one more that I looked at on the last page, like letter A, and then I could talk about B. Yeah, maybe a little bit about C, but maybe A and C. So this one's just one of those answers may vary kind of situations. It does say factored form, less work, so I don't have to multiply out. Has 2 negative roots. What's the word root mean? What? That means zeros. Maybe I skipped over that too quick with my second hour as well. Some of our older graphing calculators, like the TI-82, I believe, had the word root where their 0 is in your calculator. So it's a common word that's used in math. Now look at the limits and behavior. As x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to positive infinity. So what that's saying is that's the end behavior. So that requires that I have a negative leading coefficient. So it has 2 negative roots and 1 positive root with this end behavior in factored form. Answers may vary. So y equals, pick a number. I don't care. 7 just popped in my head. So that's the leading coefficient, though, -7. I just made one up. 2 negative roots means I'd have 2 plus factors. So make up any number that you want. 1 positive root means I'd have a negative factor, or x minus 3. That means 3 comma 0 would be an x-intercept. And then that's it. It says factored form, so that's all we got to do. All right? And then, skip over that one. Just know that multiplicity 2 means x minus 3 squared, right? So read that correctly, then it's more of the same. And then this last one, radicals come in conjugate pairs as well, mostly, if your polynomial is going to have, in this case, real rational coefficients. I think we'll talk about that next or this week, maybe, when we're talking about factoring and all this other stuff. All right, and a leading coefficient of 2. Okay, so in this case, written in standard form means we do have to multiply out. You would do these 2 first again. All right? If you did x plus root 5 times x minus 1, you're causing your own problems. Because what's going to happen to the middle term yet again, everybody? It's going to cancel. X squared, root x, root 5x, and negative root 5x. Hopefully you don't even have to write it. And then negative root 5 times root 5 is negative 5 free. That's why that becomes really easy, and then you go from there. All right? Oh, fine, I won't be lazy. I'll finish off the notes with a little foil and then leave you alone. Wait on that too. I mean, you don't have to, but I think it's just a good decision. Oh, that's the easy one. Minus x squared minus 5x plus 5. Pen, come on, you're almost making it. 2x cubed minus 2x squared. Not exciting notes on a Monday, huh? But oh well. Foil, foil, foil. Okay, done with that. Go ahead and do your stuff.